Hey, what's up? It's Jake from Nimbus DevOps, and now we're going to get into some cool stuff. So I'm going to slow down a bit, and we're going to camp out on list comprehensions for a little while. It's a very cool tool if you know how to use it, and so I wanted to show you how to use it and why it's so cool. So I made a little template, I guess, for scripts. And what I did in here is I just imported the timeout library and then said start a time, and then I'll write a script, stop, and then print out the amount of time it took to run. And then do the same thing, and we'll write another test, and then do the same thing, and we will write a third test. And then we'll just be able to see the difference between how long each of these takes. But we'll also be able to see when we look at the code how concise it is, how Pythonic it is. So let's get into this. So let's say I want to take in range 10, so numbers 0 through 9, and I'm going to take those numbers, and what I want to do is I just want to return the square of each number. So 0 squared, 1 squared, 2 squared through 9 squared. Okay. So how would we do that? So let's take our original approach, which would be to create an empty list, okay, and then I'm going to do a loop. So I'll say for n in range 10, and then we want to do something, right? We want to get the squares. So let's just say squares for our list dot append, and then we're going to append that with whatever a value of n is squared, and that's it. And maybe at the very beginning, well, no, we'll just leave it like this. So that's it. So 3 lines of code, pretty simple, pretty easy, right? And if I wanted to, I could just take all of this code here. Let's just comment this out for now. So I have one test, and let's see what happens when I run this. I can see that it takes that. Now, also, while we're here, just so we can see it, let's print squares. Let me pull this out. Loop, print squares. Okay, so we can see that this works. 0, 1, 4, 9, 16, 25, 36, 49, 64, and 81. And notice the time it took to print. When you look at the original time that it takes, and then it takes almost twice as long when you need it to actually break out of this for loop and print. So printing is expensive, right? But in our code, we're going to be using this for something. So I'm not going to be printing this, but we do want to just see that it works. So we'll try it with print and we'll try it without. So is there a better way to do this? Well, yeah. So there's probably a better way to do this. So let's take test 2 and let's go try something else. So we could try something different and say like squares equals map lambda and then n, and then we'll just go n squared b, n squared range 10. And then we'll take that and we'll just turn this into a list, squares. And then we'll just print squares like that. And you could even make this shorter by saying print list squares. And then we'll stop the timer and then we'll print the second time. So let's check this out. Okay, so I get the same answer, but notice that the second one is a lot faster, right? Now maybe that's because this is cached or something. Let's try commenting this out and see if this impacts the runtime of our second one. Yeah, see, the second one's still 4.9, 5.3, 6.1. That takes a long time. That one's really long. So now what? Well, let's try something even different, more different. Okay, so up to this point, this code is how we started. This code is kind of where we left off, right? But maybe there's an even better way. And there is, because the more Pythonic way to do this, it would be to use list comprehension. So let me show you what that is. So instead of doing that, I can just say print, let's say I'm going to make a list, right? Squares. Okay. I could just say let's make a list, and inside that list, n squared for n in range 10. And that's it. That's it. This is the whole thing. So essentially what we're doing, and this is super simple, right? So we've placed a for loop inside these square brackets, and that would be, and we're iterating through that list inside of here. And this is a much, much, much more effective way to do this. And if we just print squares here, we can take a look at our comparison. So we can see 6.1, 2.8, and then 3.01. So these two are close, but the second one was actually faster. Still a little bit faster. Let's try a third one. Still a little bit, well, our list comprehension one was faster this time around. So you'd have to maybe take this and maybe write a test script that just ran this like thousands of times and then made some sort of distribution graph that showed what kind of curve is there for performance. Like, okay, if you ran this 10,000 times, script 1 on average takes this long. The median, it takes this long. And then what kind of curve do I have? What's its limit, upper and lower range, right? And you could do that for each one, and then figure out which syntax would be the most appropriate based on performance. If you don't print anything out, okay. So if we take the print out, oops, not that print, this print, we just want to kind of perform the operation. So for n in range 10, squares.append n squared, and then we'll print out the time. And then we'll say start the timer, squares is, and then use a lambda, and we're just setting that. And then we have this one where we just do the same thing inside of the lists, inside of the square brackets. So now let's see. You can see that the second one was way faster than this first one. So what is there to learn about this? Well, I think my takeaway from this is much, much, much more elegant. But that's for people, right? This lambda approach is way faster, way, way faster, okay? But if you were to print all of these, they print the same thing. It's just a matter of whether or not you need it to print something. But you can see just how much faster using lambda is. I mean, consistently across the board. If I just run this a bunch of times, it's way, way faster. So it doesn't mean just because something is elegant, it's simple, it's compact, it's one line, that could be really nice for you for readability. But if performance is something that you want to take into consideration, making one-liners isn't always the best answer. or in this case, these are both one-liners. Um, Using something like map lambda, blah, 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 may be harder to understand for some people. Whereas in this one, I think it's pretty self-explanatory. The code is almost self-documenting, but it's not nearly as fast as this one. So list comprehension is super important and you need to know how to do it. Absolutely. And you're going to use it a lot. But it doesn't mean it's the best way to do something if you're trying to make something performant. Sometimes it might be. You just need to look at what you're trying to do with your code and then decide for yourself, is this something that that makes sense that I want to do? So now let's try to do something a little more complicated. So let's say that we're going to do like an odd even type thing, right? So if we want to do that, let's see if we can make something with list comprehension. So let's filter out all the odd squares in here. Okay, so let's say that we're going to use a map and a filter, and I'll make a new file called odd.py. And actually, it should really be called even. I'm going to filter the odds. Okay. All right, so we have even.py, and we're going to use map and filter to find even numbers in a list. Okay. So, let's make a sequence 1, and we'll make a list, and you're going to see me break these parentheses up to make this a little more readable. And I'm just going to make a map, just like we did before, lambda n, and we'll just say n squared, but then we're going to filter, and we'll use another lambda to filter n, where not n mod 2 in range 10. Makes sense? Okay. So this is using the map and filter. Okay. Then we could also write an equivalent, but using list comprehension. Okay, so stop for a second and think about what we did last time, and then look at this code and go, how can we make a sequence 2 list without using map and filter? Okay, so it would be the same thing we did before. We would just say n squared for n in range 10, except we say if not n mod 2. And that would be the version of list comprehension. So we're performing all of this inside of the list instead of wrapping a map with a filter inside of it, inside of a list function. So we're just directly creating the list and then performing all of the operations inside of the list. Okay, so now let's go ahead and print sequence 1 and sequence 2. And let's also print sequence 1 equals sequence 2 and see if they print the same thing. It should say true if it's true. Okay, so let's try this. And yeah, hopefully that works out okay. So let's go Python even. So here's our list, true. Cool, makes sense, right? Oops. So this is essentially the same thing. And what you're seeing now is we started with something simple of just creating numbers. But if you did need to do some sort of manipulation, you can do that still inside of this list comprehension without doing a filter. But since I went over map zip filter for a reason, and that's to show that you can still do these things inside list comprehension. And this is much shorter, much more concise. Now, if I take my timer, okay, and this is something that when I'm going through the book does not do, is explain the repercussions of your actions. So we'll say time 1 here, and then we'll stop the timer, right? And then here, I'm going to start the timer again. And once it's done, I'm going to stop the timer, and we'll print out time 2. And then we'll go ahead and print these. And I don't really need to see the numbers now. I just want to know if it's true or not. Okay, let's try it. You can see in this case that the list comprehension is much faster than mapping with a filter, and that you still get the same result, right? And that's essentially what, if you're writing tests or something like that, that's essentially what you want to look at. So in this example, using a map with a lambda was much, much, much faster. But in this example, just because we're doing this, we're performing a different calculation, the list comprehension was much, 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 much faster. And we could just check this a couple times. It's consistently faster than a map and filter. It was slower this one time. Yeah, the second time. Now they're getting to be about the same, and now it's much faster. So I think it's safe to say, just based on a few performance evaluations, that this would be the preferable syntax, because not only is it easier to read, but it's also much faster. So there you go. The difference, the whole point of learning about list comprehension right now is about readability. Okay, I'm throwing in the performance thing just so that one thing that people don't really talk about with list comprehension is performance. And so I wanted to go over both just so you can see, like, oh, okay, there is a performance consideration that I need to make when I code anything. But for now, what I'm going to do is I'm not going to time it anymore. You can use this and time everything you do on your own. We're just going to focus on the readability of the code. So that will be the focus of this, okay? And if you look at the readability of this, it's almost English, right? So like this variable is n squared for whatever n number in a range 0 through 9, as long as n is not mod 2, right? So, I mean, I think that makes sense. So there you go. If you have any questions, let me know. But if not, I'll leave you with this. So the Python documentation says that a list comprehension consists of brackets containing an expression followed by a for clause, then 0 or more for or if clauses. The result will be a new list resulting from evaluating the expression in the context of the for and if clauses which follow it, which I think it makes sense, like, if you think about it for like 15 minutes. But if you just, I think if you just code it yourself and look at the difference and then just start to read it this way, you'll see that it makes sense. You understand what it does. And that's really list comprehension. So, yeah, I'll leave you with that, and we'll move on to nested comprehension.